Students, our last topic for Chapter 4 is going to be antiderivatives. Anti what? Antiderivative. It actually means doing a derivative backwards. Now, perhaps I have mentioned this terminology at some point throughout the first half of this year. But if I haven't, what you're going to discover is that the second half of the year, it's all about antiderivatives. And so really this lesson is meant to be a very simple preview, but it's good practice. It's good practice to get you guys to start to think about what's coming next. And we call that antiderivatives. If we're going to do a derivative backwards, that means that I'm going to start with the derivative. So if I give you f prime equaling 4x cubed, well, that means I gave you the derivative. What function did that come from? What kind of function is going to create a 4x cubed? What's that you say? A function that would have an exponent of 4? Well, I think you're right because, well, if you do the derivative of x to the fourth, you're going to bring that 4 down. Of course, that's going to give you this 4. And you're going to subtract from that exponent, and that's going to give you this 3. And, well, it looks like we found our first antiderivative. And hopefully you've also realized through this first example that what we're really doing is going back to find the original function. What if the derivative is x squared plus x? What if f prime equals x squared plus x? So where did x squared come from? That's right. Once again, it came from an x cubed. It came from a higher exponent. But what about the fact that my derivative seems to have a 1 right here? It seems like it's not going to end up with a 3 right here. Yeah, that means there has to be something waiting here for that 3. And that something would be a 1/3. If you think about it, if you bring this exponent down, if you try to do the derivative, those 3's are going to cancel. They're going to cancel very nicely to be the 1 that we have in this first position. Can you think backwards for the x? Are you catching on that the exponent has to be greater? It has to be stepped back up. What number needs to be waiting for this 2 when it comes down? We're going to bring down this 2, right? Yeah, there has to be a 1/2 waiting for it, and that will also cancel. Now, it turns out that there would be one more thing, I'll say, that would be true about both of these antiderivatives. Remember, an antiderivative is just the original function. That's right, there's one more thing that would be true about them. You see, there could be any number, any constant, any plus c, that could also be at the end of this equation. Because if you think about it, the derivative of a constant is just going to become the number 0. So arguably there could be any number at the end of this antiderivative and this antiderivative. And we call that plus c. Now let me be honest with you. If in the last 4 minutes your brains kind of went bonkers, you're not sure which way is up or down or maybe forward or backward, don't worry. I'm going to show you that both of these problems, especially because they dealt with simple exponents, well, the antiderivative can be found by using what we call the simple reverse power rule. You see, the reverse power rule basically says that if you start with x to the n, all you have to do is add 1. That is, you have to make the exponent 1 greater. And divide by that new exponent. Divide by n plus 1. You see, if I give you f prime equaling x to the n, you can just add to the exponent and divide by the new exponent, and you will surely have what's called the antiderivative. You will have the original function. Let's use the reverse power rule, and let's continue to use some good thinking to be able to find some antiderivatives. So here I have f prime equaling 2x cubed. And if I want to find the antiderivative, well, that basically means I'm trying to find the original function. We can use the reverse power rule. Yeah, all you got to do is add 1 to your exponent and divide by your new exponent. Now, of course, your new exponent would be 4. And if you do a little simplifying with your 2 over 4, that, of course, is going to come out to be 1/2. And we have x to the 4th. Oh, that's right, plus c. Yeah, don't forget your plus c. Officially, that gives us the antiderivative. Now, I do want to make sure that you're not getting confused about, which way is up and down or forward or backward. In other words, if I check this answer, if I actually do the derivative, that means I'm going to bring down the exponent. Of course, I first really need to keep the coefficient there, but I'm going to bring down the exponent, and I'm going to subtract from that exponent. Now, the derivative of c is going to be 0, so that'll disappear. And if you do a little math here, you're just going to end up with 2x cubed. So yeah, our gold equation is our antiderivative. Reverse power rule. Seems pretty handy. So how would you apply the reverse power rule to this problem? Well, first we want to understand that if I'm giving you f prime equaling 4, that of course is the derivative. But if you'd like to think about x, we'd have to realize that it's actually x to the 0. So what are we getting at here? Well, we're trying to help you to see that if you add to the exponent of 0, you're now going to get an exponent of 1. You're going to get 4x to the 1, better known as 4x, plus c. But most importantly, we realized that the antiderivative of 4, let's put that back the way it looked originally. The antiderivative of 4 is really just going to be 4x. How about this one? F prime is equaling x to the 1/3. All right, so the derivative is x to the 1/3. Now, if I want to find the antiderivative, that means I'm going back and trying to find the original equation. Can I use the reverse power rule? Most definitely I can. Just add 1. Now, I would recommend that you think of that as now 4/3, because if you add 1 to 1/3, you get 4/3, which means I'll have to divide by 4/3. Ooh, that looks perhaps a little ugly. But isn't dividing by 4/3 the same as multiplying by its reciprocal? Yeah. So it would be best if you write your answer as 3/4 x to the 4/3. You can use the reverse power rule even when the exponent is a fraction. But you can't use the reverse power rule if you have a fraction. Now, what we're getting at here is that not every derivative that we did the first half of the year was a power rule. Not every derivative involved just exponents. Some derivatives involved rules. Now, if we want to be honest, basically the whole first half of the year was learning how to do derivatives, and many of them were rules. Don't worry, I'm not going to expect you all of a sudden today to do all those rules backwards. That's why we have the whole second half of the year. But there are some of them that are simple enough that we can start to expose you to them today. Here's the deal. Something has a derivative equal to 1 over x squared. You want to try to think of that something. What has a derivative that's going to be of the form 1 over? 1 over. That's right, it's an ln. So the derivative of an ln is going to be 1 over. I just need to make sure that it's the ln of x plus 2. So it's 1 over x plus 2. So if I have an f prime that's of the form 1 over, we want to be thinking about perhaps ln's. Now, there's other rules that we did. There were trig rules. But once again, we have to kind of think backwards. We kind of have to think, where did sine come from? In other words, the derivative of what is sine? Now be careful, I didn't say what's the derivative of sine. I said the derivative of what is sine. Is it cosine? You're close. Isn't the derivative of cosine negative sine? So all we got to do is make this an opposite cosine. Now once again, don't panic. All of a sudden, I don't expect you to have everything that we learned put in reverse. But we are going to start to think backwards. And one of the ways to think backwards with the trig functions here, for example, is that the antiderivative of sine, is opposite cosine. So where did secant squared come from? What's the antiderivative? What's the original function? The derivative of what is secant squared? The derivative of tangent is secant squared. And so tangent would be the antiderivative. Now, that's one idea, basically starting to put some problems in reverse. We have one other idea we always like to show you here on this preview day. And it uses this language, finding the exact antiderivative. Now, I also have a kind of interesting function here. That is the derivative is pretty interesting. It's clearly a 1 over, but it's not going to be an ln. As you can probably see here, the x to the 3/4 that's in the denominator, well, we're going to be able to think of that 3/4 as a negative exponent. But we'll worry about that in a second. I just want you to notice that there's something else going on here. I'm giving you an exact point. Well, that exact point is how we're going to find the exact antiderivative. Ready to find out how? Okay, so f prime is definitely, at least originally, is definitely a 1 over. But let's kind of interpret this a little bit. And I don't think you're going to be too surprised at what I just did. I interpreted the 1 over 4 as 1/4, but I interpreted the x to the 3/4 as now, the 1 over x to the 3/4 as x to the negative 3/4. Now, mind you, this is still the derivative. Now it's time to find the antiderivative. Now it's time to find the original equation. How are we going to find the original equation? We're going to use the reverse power rule. All you got to do is add to your exponent. Now be careful, when you add to that exponent, you actually get 1/4, and then I'll divide by that new exponent. Now, I can multiply by the reciprocal, or I can just say, wait a minute, these are going to cancel out. So I'm going to end up with x to the 1/4 plus c plus c. Are you ready to get the exact c value using this exact point? Yeah, basically plugging your -2 in for y and plugging your 1 in for x, you find yourself solving for c. It's kind of like you're finding the y-intercept, actually. Now, 1 to the 1/4. 1 to the 1/4 is still equal to 1. So I end up with -2 equaling 1 plus c, and that's why c equals -3. Now, my answer is not -3. My answer is the exact antiderivative. What's the exact antiderivative? Well, it's this equation. It's the equation x to the 1/4 minus 3. And that equals your f of x, which again is your original equation, which is your antiderivative. I'd like you to do a little exit question. If we were in the classroom, I would ask you to do this. It's not going to take you too terribly long, but it's good practice. And I'm going to ask you to complete this using the very simple form that I've included. So just use the link, go to the form, and submit your exact antiderivative for this nice little problem. All right? I'd encourage you to jot it down on paper first, and then find the submission form, again, that I posted. All right, that officially wraps up Chapter 4. Now it would be time for you to officially start your assignment. We're talking about the assignment that involves 4.2 revisited. Yesterday, the mean value theorem. Today, antiderivatives. And do a great job. All right? See you soon.